भगवती निशेषजाड्यापः या निशेषजाड्यापः.
First of all, it's a great pleasure for me to welcome you all for this 2015 first international conference on the topic of emerging areas of power electronic applications, so which is being organized by our department in collaboration with the Department of Science and Technology, Delhi. Well, as we are all well known that the main aim of organizing any conference is to provide a platform for the technical challenges and to make a network. So in addition to that one, this conference will mainly emphasizing on the topics which are nothing but application of power electronics in the area of the electricity. That is what the main aim for this conference. So apart from that, as we are well known that so the sustainable development and growth of the people is mainly dependent upon the energy sector only. So that is nothing but which we are nowadays lag behind. So coming over here, this electricity is one of the major role, so in which the power electronic is the major application, so where in order to enhance the power sector. So especially when it comes to the application point of view, so that is nothing but let us such as mass rapid transportation, so electronic devices and circuits, so and also whatever the power electronic application, especially in the area of smart grids, so to enhance the grid capability.
Dr. V. Madhusudan Rao Garu to give his valuable speech and enlighten the gathering about the university.
Every department is to organize one international conference, one national conference, and many more workshops. That's what the compulsory they are doing. Almost all the departments, and every year they conduct these things. We don't mind to spend money to any extent. If they get sponsorship, fine. Otherwise also we sponsor it. See, you know that the conversion of solar radiation into electricity, the main hurdle is the materials, the cost of material, the so-called photovoltaic cells, their fabrication, all the designing and everything is becoming costly. That's what main hurdle. And people are working to reduce the cost of production. One alternative very recently, and people are working for quite some time, but they are getting success, is what you call it a molecular electronic material. I know whether you heard about molecular electronic materials or not. They are nothing but conducting organic polymers. They are replacing now the so-called inorganic semiconductors, silicon and germanium based. Because the main problem with silicon and germanium based is the cost, as well as it's not the what you call abundance is one, as well as the complexity in the fabrication and design. Once we make these organic polymers into this system, they are very easy to fabricate and diversity is very high, small in size, and we can also, the fabrication process or the designing process is very, very easy when you compare to inorganic, the so-called semiconductor materials. We can easily convert them into both P-type and N-type semiconductors, the organic polymers. There is a process. So I hope within 5 years, the organic polymers are going to replace the so-called inorganic silicon and germanium based semiconductors. That's what the real problem. And I'm very sure that we are going to completely, very easily can convert the solar radiation into the electricity.
We are extremely fortunate to have with us this morning Dr. Pawar, Professor of Electrical Engineering from Oman, who is a specialist not only in power electronics, but also on energy management. Very shortly we are going to have the capital year. Capital region is going to be in Amravati. We should be the trendsetter. We should be the leader and tell the other universities how to reduce electricity. Because enormous amount of energy is being wasted in this campus. I'm sure this conference on power electronics application, which has a direct bearing on renewable energy technologies, on energy conservation, energy efficiency, and energy saving measures will address, and the deliberations in the next 2 days will find an echo in the form of a report so that we'll work on that on a mission mode. I wish the department.
Good morning to one and all. I am Suman, working as Assistant Professor in Electrical Engineering Department of Vignan University. Today it's my great privilege to introduce our chief guest, Dr. Dharmasar Pawar.
So today this event, which is sponsored by DST, that is the Vignan University. We are working with the knowledgeable university. That pride we should have. Definitely that makes us to reach the goal what we have dreamed. Some people might have kept a dream that I want to become like this, I want to become like this. People should call me like this. So that is the chance of reaching through that level. So that way, congratulations to all of you that you are working in a university. That is the government of India. We appreciate that they are trying to check the quality of the private institutions, self-financing institutions. They want to elevate to the level of university. When I visited university in Bangalore 1990, I saw so many the flags were there in front of the university. So that time I saw that I wanted to join university by seeing the various country flags. When I got an opportunity to join a university, because university having such a wide exposure of knowledge. So you are working under that particular umbrella means really we have to feel proud ourselves. We should feel proud, and we have the brand which is supporting us, and we should contribute accordingly. So that is the one thing. I congratulate all of you on getting in 2009 as a university. It's really great. You should feel proud and give a big clap by yourself that we have achieved something. This particular, the key role what I was talking, Dr. Durga Sukumar, I will congratulate him on the success story of the first conference. Really a lot of lacunas will arise, and I found all done very excellently with the cooperation of his team members. Really we have to congratulate them on this event, because the knowledge teaching in a classroom is the one kind of knowledge. The knowledge which we are teaching, bringing the knowledge from other part of the world and putting it one place, or other part of the local area or the region or the entire country and putting it on other side, really it is a challenging thing. And keeping the title as itself the international conference, the responses will go very, very high. In coming to the part of the power electronics, I would like to say the power electronics, as somebody said me, you are high voltage engineering, you are something renewable energy, you are even power system. Basically, I'm a power system man, but the power electronics is also my interest, wherein I taught the 2 to 3 times this particular subject. I want to call it, in present day scenario, I want to name it as a high power electronics. Hope so it may suit the more better title as high power electronics, because the voltage level also high, the current level also high, and with respect to these two parameters are increasing, the power should be very high. Because why power high? Because as our Dr. Commander Raghunath Garu said that the energy saving is an important aspect. See, if you feel that the energy saving is an important aspect, we should start feeling from the generation station, transmission system, as well as at the distribution system. For giving me this another opportunity to present my idea. The application, one of the greatest applications of the power electronics is that we have to save the use is the transportations or other areas also they save. And one of that one is renewable energy. Renewable energy is cost-effective analysis. I have taken here the solar and the wind power. So because in this particular area, so what we are trying to that did is somebody said it's not cost-effective, right? So somebody they say give a problem, then we start thinking. Not cost effective means then why it is not cost effective? As one of our the other day, Dr. Madhusudan said that there is an organic, right? Organic kind of the thinking. And are they suitable? If somebody says they are, these are the things coming, are they okay? How they are okay? Are they environment friendly? Okay, they are environment friendly. Are they sustaining? Sustaining means is lot. There is another big word, sustaining. Sustaining is the one wherein it should be cost effective, it should be the environment friendly, it should be that they withstand long life, it should not give the trouble, it should, so many things are there, and it should slowly you should increase the energy efficiency in the system. That expectations will be very high. Sustainable, smart, these are all the very efficient. These things, when we comes to this, one of the parameters we are taking, only one parameter we thought, why can't we reduce the cost of this solar somewhere without thinking? Sometimes it's not possible to do the chemical side, or sometimes it's difficult to do in some other areas. So why can't we do in other sectors? That way, I thought these are the 16 panels we have installed on our college at the top floor of the campus. And that time myself and he is our registrar, Dr. Nizamuddin, and the next, I think this slide is there? Okay. He is Dr. Ravinder. He got the funding from the TRC. Actually, TRC, I brought the CDs. I think that CD I'll try to share that the TRC, the Research Council of Oman, wherein he got a funding of around 148,14830 multiplied with 163 rupees per day. I think now today is 163 or 162 is there. Okay, that is the amount of money given by the government to think that there is a renewable energy requirement can be taken into the account to produce the water. That's all. Because in Oman there is a scarcity of water is there. See, your research it goes with respect to what you wanted to go in the direction. That way, this is the very good research they found. See, that is very simple. It's not that much difficult research. See, the government is thinking in a very different way. Government always wants solutions. Sometimes they don't want a complex the research. They want a simple research, application-oriented research, useful research. That way they are thinking. Okay, please, this way they got 148,000 into 162 rupees or 3 rupees. That is the amount they received by the government. I was there when I went to 2010. The beginning, I was there with them. So with this, these are the power electronics, which is supposed to be a key, inevitable. Power electronics is inevitable. So I cannot say that some part of the system can be taken out. Tomorrow there may not be a suitable, that tidal energy is not suitable, we can take out. But where power electronics is the center of all the sector. Whether you take the solar, you take, and it should go via your the power electronic device, and it is you take wind energy, you take, or any other type of turbine wind energy you take, for any other application you take, the smart, whether the smart kind of the devices. Okay, all things, there is a main path, the main person who is behind the your thing. You see, you can see here the control. This is the your or diode, or the bridge, which is helping us to convert to AC, and this is again AC is converting, and here it is again this. So this is a switch, a simple switch, which we feel that is the one which is making the center of all applications. It is related to this one. So one of the applications I have taken this part that is today for the discussion. That is here I don't want to say presentation is very simple, solar and energy relevance, and it is there is a past and future. RER is actually the renewable energy. The reference is there. Actually, in case of Oman, this introduction, renewable energy must be a positive impact should be there. This everybody knows it. This is because entire world is looking for this side. And first thing we should understand what is always. I used to tell one simple thing. So preparation of tea is simple, my friend. Preparation of tea is simple. Anybody can do. Even a 5th standard kids also within 2 minutes they can learn preparation of tea. Preparation of tea for the 1 lakh people become challenging. Am I right or wrong? See, I want tea for 1 lakh people. Is it automatically we get tumbled ourselves? 1 lakh people, how much sugar? This is the way expectations are there in future. So your projects will be appreciated very highly. So first thing, we should have wider range of your problem. We should expand your problem. So first you should, when somebody says the cost effective you're doing this, understand what is the reason behind the environmental conditions or the reasons, whether you take that weather report and all. So we have to take, this is the entire country as Oman we should take into account. I should make the entire country for the Oman or entire global. This is what famous for the US people. They think everything always globally. think globally means it's again a very big word. Your problem should be, or your concept should be utilized by the entire world. Somebody asked what is the reference or impact factor of the paper. You know, people will say impact factor paper is more or less. What is impact factor? Is simple, very simple. Somebody is using your concept. That's all. Kirchhoff law impact factor how much? Kirchhoff law, Kirchhoff current laws. It is you cannot number also. No journal is there to rate the impact factor of the Kirchhoff law, Kirchhoff current law voltage. Everybody is using entire world. So like this, your impact factor is your knowledge somebody is referring. That is the impact factor. So this is a bigger level we have taken first into account. In this case, we have taken the picture wherein the latitude, longitude, wherein the entire weather conditions we have studied. And these are the weather conditions of the radiations in Oman and wind. So this is one particular study taken from DGM, Directorate General of the Meteorology and Air Navigation Department of Oman. So we have taken the details of the various locations, what is the intensity of the wind or intensity of the solar is there. So those things we should take into account to justify, to say that I am trying to submit a report which is need for the society. So this is actually, if you take, this is the RERA reference index, you say the Oman is standing very good compared to other GCC nationals. They will compare with their own, first they want to achieve in that GCC. GCC means the Gulf cooperative, the cooperative countries. That Middle East we call in India. So this is in this case we have taken a very simple, provide a cost effect. This is a very important decision parameter, my friend. This is always makes the person to think. Let us say cost effective, the flight is there, our train is there, cost effective and quality, everything is there, then we appreciate that one. So that is the most challenging thing which expects from the engineers now. So this is the safe, these are all other, automatically they join with that. And the main objective here is the cash flow we have taken into account. And the renewable energy resource index, this is then again a report, I don't want to take much time here. This is the types of, this one is a PV we have taken into account, PV. Photovoltaic we have taken. This is other kind of things that we have not taken into the application. And these are the things we should know these characteristics very well. This is possible. Just now I was discussing with the registrar. He said that the solar energy, the coming is how much is coming. Is it a capability to produce energy in all the years of the day, or only the night is not there? What to do with night? Okay. One thing I want to know is temperature is good. Is good. Solar energy, people says, if temperature is good, it is good. Is it good? Anybody? There is a problem with the efficiency of the solar panel. In Oman, they felt the solar energy is very good because very popular, very big popular. Solar energy is very nice because the desert conditions or in Oman, the temperature is very high. So we will put solar panels. They put solar panels. The life efficient solar panel or life of the solar panel, we expect at least 25 years or 20 years at least. So 15 years or 10 years, all solar panels spoiled. You know what is the reason behind that? A simple reason, not any technical reasons or design reasons, anything. Simple weather condition is more than 42 degrees centigrade. It has gone up to the 52 degrees centigrade. Because of that, the efficiency lifespan has come down. Solar panels are spoiled. Because solar panels are spoiled, that study they are doing now. Any researcher, if they do some researchers, that weather conditions are supposed to beat. That is always very important aspect. So, the 24 to 42 is the temperature wherein your efficiency of the solar panel goods very good. If not, what to do? That is we have to think. Alternative, whether we would provide shade or the only intensity of light we want. We don't want temperature. We don't want more than the required temperature. So this is the thing. This is the power generation per square meter area. These are the ranges. This range is good suitable in this country. That particular country have taken. And we have insolation and what time it is available. Those things we have to study and optimize our thing. And this is this is the one project we did, the concentrating solar power controller. And this is very difficult. You know, this looks so beautiful picture. Everybody believes this one also. You try to do this one. Take some mirror and try to keep in the one center point. You try to do. Why? See, drawing is so easy. Am I right? Please see the drawing, it looks very comfortable, reflecting and all are coming. But when you do practically, only one sun is there, not 10 suns are not there. One sun is only one. It's very difficult to adjust that angle, sitting and saying. Only sometimes this will not somewhere it will fall, or again that will turn. The dynamics are very difficult. But looks wise very simple. Theoretically it appears as if it is giving more power. But when you try to do it, there you find the magics or the things, difficulties. Oh, this is not so easy. Okay, this is another tough kind of thing. This is what we did one project. This is the one convex lens and falling. So convex lens, why can't we use a bigger convex lens so that the more efficiency of these solar panels will increase? So I try to keep this. You see, people will feel that their two suns are there, and this is wrong. Only one sun will come and fall here. So that is the beauty of this one. So and this we tried again another. So when we did mistake here, we thought, why can't we keep the sun is moving like this? So intensity is very high here. Am I right? We don't want to keep that much temperature. We don't want. Intensity we want to reduce. Very simple concepts. Very simple. We have taken the concave lenses and convex lenses and convex lenses. So when traveling this particular thing, the sun, it gives more intensity. Intensity I want. Temperature I don't want more than 40 degrees centigrade. Intensity of light is very important to generate the more amount of power. So this is the simple thing we have done, and this is the equation. This is all we have taken into account. These small things, and like this we have done. Another interesting thing we have done. See, this looks. So very interesting thing I will tell you. I will not tell the more theory point of thing. Directly I will come to the point. So solar panels, people say that it is okay, fine. It is crystalline level, molecular level, lot of research, chemistry and all that. So what about the weather condition? Weather condition giving a dust. In case of 3 countries, very popular. Dust is very popular. One is Oman, one is Australia, one is India. 3 countries, dust is forever. It is without passport. They travel from one country to other country. There is very popularity of dust. Dust again, various ranges are there. 0.005 micron level to the some up to 5 centimeter we consider as a dust only. Okay, those things we have to clean. I thought it's very simple. It's a dust cleaning is what we put water and clean. Then a big research is done in this area again. So when I referred various, see any area, my friend, is truly speaking. Don't think it is simple. Don't think it is simple. Every area is challenging. Every area, international level, the competition is there. I used to tell, sir, this is very difficult, this is engineering. Then go and run. Start running now onwards, 4 years instead of, and become #1 gold medalist, you become gold medalist. That is also a good work, right? So it is difficult, that also, but running also difficulty. See everything, because meeting the international standards are, the quality is very challenging thing. So that's why this is the dust analysis we did. Simplest solution we found that, and we published paper in the Sharjah University in the last year. They appreciated, and many the companies are contacting me. So what is your technology? Nothing technology. I thought this glass is there. This glass, why can't we clean it with wiper? It's normal your cleaning of this. So there is a lot of technology, as I said, in dust analysis cleaning. There is high voltage actually we keep actually. High voltage panels we keep. The dust which is there, the charge, this acts as a conducting particle, and when you keep the two, this thing, the electrode, positive electrode, they repel each other. Automatic dust will come out. That technology using for the moon actually. This dust is not with respect to Earth started. Research started with the moon, wherein there is a lot of dust is there. That dust cleaning of that dust particular thing, they thought the cameras are becoming dusty. So that camera cleaning technique, so many are there. So one of the cleaning technique which we propose this one, and is found, you know how much percentage of efficiency the solar panel is falling down because of the dust? Professor Mazumdar from US University is claimed that 40% of the efficiency is coming down because of the dust. People are thinking about efficiency of the solar panel, and 40% they are ready to lose because of weather condition. 1% they are increasing their day and night, they are struggling to increase the efficiency of the solar panel. But they don't know where it is going to locate, whether in Oman or country where the temperature is high, they thinking, okay, good, but other side dust is there. See, these are the problems we're supposed to sort out so that the efficiency of solar panel will increase, not at only the research lab level, general application level. So there some chances are very high efficiency, increasing chances are there, rather than doing the critical research also. That is, this we did, and this is the structure which is in Oman. This is the electricity. This is Oman procurement of water and purchase. This is they have the companies, and you believe it or not, the cost of electricity in Oman is 10 Paisa. Actually, Paisa is the same word taken from the Indian rupees. Once upon a time in Oman, they used to, they don't have any, the currency. The currencies were Omani currencies, Omani currency, Indian currencies were using. So because of, now they stopped using almost maybe around 15 years or 20 years back, previous, or maybe 30 years back they stopped. Now they brought their own currency that is called Omani Riyal. So the 10 Paisa is the unit of, means almost it is less than the Indian cost. Actual cost of generation is 50 paisa, or 870 paisa it cost. Almost 70% the electricity bill is paying by the government there. I found that. So I am standing there. Can you see that picture? So this side they are not using anything. See, this then they are not using for any other purpose. This land is waste. I mean, it is far away from the city, but still it counts the value. So this is the one we have taken into account. Why can't we grow something below that? And what to grow? These are simple things again. What to grow? See, these are the things we can grow. This land is. I discussed with one of the person who is in Oman, and he said that I am not using the land which is growing land. In desert we use wasteland. What he said? I use a wasteland. So then I made this again challenging thing. So we use the pipes like this, water pipes. So and why can't we produce the vegetables or veggies? Vegetable manufacture needs, or production needs the solar, but not the very high intensity. And again shade also required. That shade under this panel, why can't we grow? So this is what we try to grow this below this panel. Below this panel we try to grow these vegetables and try to increase the efficiency. And other found this particular thing was felt very happy by the research council, and they are trying to fund for this project. Though it is a very simple project. In our college also interested to put the solar panel below which they want to grow something. And they want to make garden something. Because the temperature withstanding, again you should know, it is looks simple, again analysis become very complex if you go further. Oh, because this is a good idea, but further we have to know the what vegetable I should grow, how much I should grow, what is the space, all this. I told a very simple example, tea preparation. My title of the thesis is the power flow analysis for radial and weakly measured electrical distribution. This I can link with solar, I can link with UPFC or any other power electronics area also. We can link this particular concept. Nothing like that. The generation, transmission, distribution, wherever comes, all will play a role. Power electronics, a power system, or distribution, etc. Let us take here in this first concept. I want to tell my direct papers where exactly this may help you to understand something. The problem is the network is complex, having the distribution network as a radial, no problem, my friend. Radial network is not at all problem. It is like this tree structure. When it comes to some loops in that, the challenging become very high. Some loops means weakly. Health is weak, we say, no, like that. Some weakly mesh. That time the algorithm works very, very critical. The convergence will not going to happen. So many people will ask why convergence is not going to. See, the variable which are there, that they are not going to be one. See, I want to ask very simple question in this convergence. Can you take a photograph of a person? Because we should understand, otherwise there is no meaning. We should know the exact meaning of that, what they are asking. Convergence, they say, what is the convergence? When you do iteration, what is the convergence? Can you take a photograph of a person who is short person, other is tall? Can you take a photograph? Yes, we can take photograph. Okay, but problem comes with the person is whom you are focusing. Problem is to whom you are focusing, whether you are focusing to the short height person or long person. If you focus for the short fellow, the top fellow will not come, or short. See, this is the difficulty of the variable, my friend. So that is your challenging thing, how I should solve the problem of the things. That is the R by X ratio I call. R by X ratio is very high. The substations, the generating stations, slowly it becomes low. So the range is going to change. That way I thought this is the one network, radial network, and I will tell you where exactly I have contributed. The first place is, I thought in the very beginning, this is the network, and in this case only one contribution I have taken into account, and I will tell you very simple. So this is this part is the network. This is the bottom side network, the top side network. Here what we felt is, so the analysis the others have done in one way. Why can't I found in the iteration process, why can't we take the most recent value? I want to tell very simple. In this case what I did is something like I've taken the data which is more accurate and feed it to the system. I got fast results. Is it okay? That I did. I have taken this one here, one equation, which is the most recent data I have taken in this case. So this is the one which I have taken into account, and I found the solution. Most recent data I have tried to add. And another thing I will tell you, when the iteration loop process going on, your guess should be correct. People say you guess at 1 triangle is 0. I don't believe that one, my friend. Somebody says no. Anybody power system engineers here? Power flow analysis or power system, electrical, you might have studied already. Many people have might have studied. 100 angle 0 you take and do process. No. If you have a skill in your knowledge, you should analyze the network behavior and you can choose different guessings. And you should guess the right one. Automatically reach the solution faster. Like researching something, okay, which we don't know. So that has to be searched with your proper guessing. Okay. These are the things which I have done in the first beginning. And this is another one, same thing, but power relation things I have taken instead of current relation. Second, this is called as, the title is like this, graphic information based power flow for radial distribution network. Second paper. And here I made it the power way, power I have taken instead of the currents. So this gives the faster solution still.
I'm here to present the topic comparative study of speed control of 6x4 switched reluctance motor using hybrid fuzzy logic controller. Fuzzy logic controller is utilized to control the SRM speed. Here for controlling the speed we are using different controllers and also a combination which is HFLC. Firstly, coming to the introduction, the switched reluctance motors are the electric motors which runs using the reluctance torque. These motors can operate up to very high speeds, up to 50,000 RPM. So let us see the construction. The switched reluctance motor have salient pole rotor and also salient structure in stator. So it has double saliency structure, and because of this double saliency, the torque ripples in the output get reduced.
I am doing research on mitigation of power system. Mitigation of subsynchronous resonance oscillations in power systems. And so first of all, I have to introduce about what is meant by subsynchronous resonance in power systems. So why it is occurring in the power systems? So because the power system is having, it is a large network consisting of mechanical systems such as turbines, generators, exciters, and all the electrical network consisting of various components, resistance, inductance, and shunt capacitances. So due to that, one system will be operating at some frequency and another system will be operating at some other frequency.
We are presenting paper on analysis and design of AC to DC boost converter by using IC UC3854A. Abstract. This paper presents the analysis and simulation of AC to DC boost converter by using IC UC3854A. This paper covers the specifications and importance of boost converter, power circuit design and power factor correction, and IC UC3854A controls the boost converter pulse width modulation to 0.99 power factor. The power circuit input voltage range is 220 volts to 300 volts and the output voltage is 450 volts. Boost converter. Boost converter is a DC to DC converter. The output voltage is greater than the input voltage. It is a class of SMPS and having two switches, one energy storage element and a capacitor. The operating principle is when the switch is closed, the inductor current flows in between the positive and the negative terminals of the input. When I am giving the input voltage for certain range, I have the output have to be same. So for example, when I am considering the input voltage as 220 volts to 300 volts, the output voltage have to be 450 volts.